All right, and welcome to week 2 of the Ideal Qualitative Study with a Quantitative Component 6-week webinar class. William Bannon here again, of Stats Whisper, bringing you the second week in which, so according to our webinar agenda, the second week will be Quantitative Analysis Part 2. So if we look at our 7 steps of quantitative data analysis map, we see that we're focusing on steps 4, 5, and 6 this week, which is actually the statistical analysis portion of the 7 steps. All right, so we're going to start with, of course, step 4, which is univariate analysis. So here's our study map. All right, so we have our research question 1A. Right, so the dependent variables class attendance measured in 1 to 7 days. And our covariate predictors of that are age, right, 1, 2, doctor-prescribed meditation classes, 3, class enjoyment, and the independent variable, class assignment, morning or evening. Remember, that's what we want. That's a variable of interest. We want to see if it's the strongest predictor of class attendance. Now, if we look at research question 1B, it's all the same except the dependent variable has been dichotomized, right, into attended class at least 3 days a week, yes or no. Right, so in essence, we have 5 study variables to bring into univariate analysis. Okay, so if we break down the term univariate analysis, we see uni meaning 1, var meaning variable. So we see we're presenting an analysis of 1 variable. Right? Sometimes it's called descriptive analysis because we're describing variables. So we can use as a guide to select the correct test the univariate test key. Right? So that'll tell us in SPSS what test to do. So it's rather short, right? So on the left, we have the variables, either categorical or continuous. Remember variable structure, right? Categorical, continuous. Then on the right, the univariate test to use would be the frequencies, frequency analysis for each of those. And here we see, when we're looking at the categorical variables, we may look at something like the number and percentage of residents within each category, number of male, female, and so on. And when we're looking at the continuous variables, we're looking at things like the mean, the standard deviation, minimum, maximum scores. That'd be for something like age, right? The average age, the oldest, the youngest. Now, to run frequencies in SPSS, we would take these steps: analyze descriptive statistics and frequencies. As a matter of fact, we're going to go do that right now. So here's the text of instruction, and let's actually do it also. Okay, so here we go, and we have our SPSS. We have our sample study, right? So this is variable view, where we can see our variables. This is data view, where we could see the data. We could do it in either of them. So we go to Analyze, Descriptive Statistics, and Frequencies. Right? So we put over our predictors, age, right, class enjoyment, and you can also stretch this out because the column's a little smaller. Doctor prescription status, right? We can put in our class attendance, right? And class assignment, right? Our independent variable. Actually, you might want to put class attendance last so the predictors are together. Then under statistics, we could click, mean, median, mode. Usually we just use the mean, unless it's one of the others is a better measure, but usually it's a mean standard deviation, right? Minimum, maximum. Then we say continue. It's kind of nice to have under charts, right? Histogram with the normal curve. So if we have a continuous variable, it'll put a normal curve saying what a normal curve looks like, a normal distribution, and what the actual distribution is. So now we can say continue. Now here's the point where we either say okay and run it, or we say paste and save it. Right? So suppose we want to save it, right? So we could have a record of what we've done. And if we want to run it again, all we have to do is, right? So you save it as just as any other, save as just as any other document, right? And you just save it to wherever you'd like. Then you highlight it and click the green arrow. So you get the same result as if you pressed OK, but now you got a record, see? So we use the variables age, enjoyed, class. So we have like a record. And we click the green button, and we get our results eventually. Okay, there they are. Okay, so there's our results, right? So we see the mean age, 79, right? Youngest, 61, oldest, 94. In fact, and then there's the distribution here for age, 61 to 94. So as a matter of fact, these are in tables, right here. So if we keep going, we see there's our tables, right? So we put our continuous variables here. And so there's the age we were just looking at, 79.29. Right, the mean attendance is 3.69, so it's 0 to 7 days. So the average person went about 3.5 days. 3.5 would be half, so it's a little more than half. Then the mean of class enjoyment, that's 3. So it's kind of like in the average because it goes 1 to 5, so 3 is pretty much in the middle there. Then we look at our categorical variables, right? So these are where we're presenting the number and percentage within each category. So we see the first one is doctor prescription. So we see the first line is no, there's an N of 40. So that means 40 of the 100, which is 40%, did not get a prescription by the doctor to take meditation classes. Recommended 30, so 30 people, 30 residents, 30%. The doctor recommended they take meditation class. And finally, yes. In the yes category, there's 30 that were prescribed to take these meditation classes by the doctor. Then we have class assignment, which you can see is 50-50. So about 50% of the time people were assigned morning classes, and 50% of the time they were assigned evening classes, right? Very nice distributions, right? So if it was lopsided, like class assignment, the morning was so out of 100, if 90 had morning and only 10 had evening instead of 50-50, there would be implications, right? So it's nicer when it's spread out as 50-50. Now, recall, please, that we have to dichotomize class attendance, right? Make it into 2 categories. For those that attended 3 days a week, right, 3 or more, versus less than 3 days a week. So if we look at that distribution, which is produced in the frequencies, on the left-hand side, we can look at the values for days attended a week. So it goes from 0, it's a couple of zeros, 0.5, 0.81, then it goes all the way up to 2.9 and 3.0. So that's the dividing point, right, that we want to look at. So those are people that attended on average 2.9 classes per week, a little below what we're looking at. And then after the cutoff point, 3, and then it goes up from there, 3.1, 3.2. So that's where we want to categorize these people on either side of this line. So you would do this through a recode function in SPSS. There's certain things in SPSS, just like 3, 4, 5 that you really use constantly. And this recode is one of them. Okay, so these are the directions to do the recode in SPSS. Right, so if we actually go and do it, this is what it would look like. Right, so go to SPSS, right, so transform, okay, recode into different variables, right, because we want to create a new variable, right, showing those 2 categories. So we go to, right, class attendance. That's the continuous for 0 through 7 that we're just looking at of class attendance. we put it under here, we go to the center. Now we give the new one a new name, right? So we might call it, we actually, this is in the database already, but we call it 3 days or more. Whatever makes sense to you. And then we click change. So that's our old variable, going to be turned into our new variable, and we have to set the criteria for our new variable. So you go into the new values, right? And under old variable, old value, right? We might go to say range. So we know that someone attended 0 classes, so we put a 0. And then the highest in this one category is 2.9, the category being those that attended less than 3 classes. We saw that. Now we're going to give them a 0. So you have to stop thinking of 0 as 0. 0 means no in this context. So when you see a 0, just pretend there's an N on the other side, right? 0 is no. Okay. Then we click add. Now for the other old values, we have to recode 3.0. And what's the maximum they can go to class? 7 days, 7.0. 7.0 is going to be 1. 1 is yes. Add. There we go. So basically, it's going to take the old variable and make everybody 0 through 2.9, right? 0, which means no, they didn't attend 3 classes, and 3 to 7, 1. Yes, they did. Then continue. And then this is a great place to paste it, because if you go to the syntax, what if we made a mistake? What if we made it 0 to 2.5 and then 3.0, right? Then there'd be people left out. And then when they're left out, we might say, where'd they go, right? Well, you can look and see if the syntax was correct. That might be the problem. So here we have the actual syntax, right? So you just run it, right? And then you would look, right? Let me see. Let's see now. There you go. And there's 3 days per week, right? That's pretty cool. If you right-click and then click, say, sort ascending, all the zeros come up, and then class attendance, the original variable to the left, is there. And then you can see, right, when you go down, right here, where it's 2.9 and 3, right, that's the break-off point. That's where the magic happens, right? That's where it becomes 1, right, when it's 3, right? And you would also, look at it with frequencies, so if we did that, right, so we click reset, and then just look at 3 days, right? So here we see, right, we have 2 groups. No is 29%, right? That was our break-off point, so it looked like it worked, which is not bad. Okay, let's go on from there. Okay, so there we go. There's our distribution. It looked like it worked. So now that's univariate analysis. That's taken care of, right? TCB for UA. Right, so then we have step 5, bivariate analysis. Right, so we're using bivariate analysis. Right? Remember, we want to select the variables that have a statistically significant relationship with the dependent variable to take forward into multivariate analysis. Then of the significant ones, we want to see the strongest predictor. So what we're doing here is we're seeing with one-on-one test, which variables are significantly related to the dependent variable class attendance all by themselves. Right? So by, right, meaning 2, var, variables, an analysis between 2 variables. Now, selecting the correct statistical test, right, for the bivariate analysis, it's rather straightforward and simple, or we're going to make it that way anyway, right? So we got to consider 3 structures. Continuous, which we all know, it goes up and down, meaning there's a lesser or greater presence, such as like how many days did you attend, 0 to 7. Higher number means more days, right? 2, categorical is 2 categories, like, the variable class assignment, morning or evening. And 3, categorical with 3 or more categories, like doctor prescription, no, recommended, and yes. Okay? Okay, stick with me now. So we're going to consider 4 tests, t-test, chi-square, ANOVA, and correlation. Right? We're going to consider 4 bivariate tests here to test these relationships. Now, we put all this stuff in the bivariate test key. Now, we have 2 variables, variable A and B. So what you'll do is you'll consider the structure of the 2 together, and right, so variable A and B, and the final column that says bivariate test will tell you what bivariate test to use, right? So categorical with 2 categories and continuous, a t-test. Categorical more than 2 and continuous, an ANOVA. 2 continuous correlation, 2 continuous chi-square. Better illustrated if, right, so if we take our variables, right, then we plug them into this table, right? So we got the 1 dependent, 4 predictors. We're going to plug them on into this table to show what we're talking about here. So here we go, right? So if you have a categorical variable, right? So if you ever do have a study and you need to do a bivariate analysis, all you got to do is figure out what the structure is, right? What the structure of each is, and you plug them into this table, and you know the bivariate test to use, right? Pardon. So if it's categorical, right, the first line, variable A is categorical with 2 categories, such as class assignment, morning or evening, right? And variable B is continuous, right? So you can see the dependent variables all in the B column. You use an independent samples t-test in the last column. If it's categorical with more than 2 categories on the next line, such as doctor prescription being related to variable B, continuous, like class attendance, it's a one-way ANOVA. Then if they're both continuous, such as class enjoyment and age being related to class attendance, you would use a correlation. Now the last one we mentioned, right, don't forget that last one, if you have 2 categorical, now this is going to be for the second part of our analysis, but if you have 2 categorical, such as class assignment, morning, evening, and class, did you go to class at least 3 days a week, yes or no, both categorical, then you do a chi-square, and that'll be later on. So now we'll implement these 4 bivariate tests to look at the first part of our study, examining dependent variable 1A, class attendance, 0 to 7 days. What explains it? What predicts it? How do we know? All right, now we'll consider the second line first, which sounds a little awkward. But, so we have our categorical, doctor prescription, our continuous. We're going to do our one-way ANOVA. ANOVA standing for analysis of variance, right? Which is, parametric tests are largely based on analysis of variance. This one's just more honest about it because it's in the title. Okay, so what it's going to tell us, right? We ask, and the SPS is going to tell us, right? What we're asking is does a significant difference exist on the mean scores of attendance for people in the categories of doctor not prescribing meditation classes, recommending meditation classes, and prescribing meditation classes? So we have 3 groups. Do they have a different rate of attendance, among them? And who's different than whom? So test assumptions, right? So we're just going to mention these here because this would make the presentation about, 3 hours long if we went through each of them. So we'll mention them. Plenty of resources. We have resources. There's on YouTube. There's all sorts of documents where you can look up these assumptions and test them. But it's important you do it because the findings might easily be skewed if the assumptions are not met. So 1, independence of observations, no undue influence of outlier scores, which is a very important one. Is the continuous variable normally distributed? Homoscedasticity, right? And then also, as we mentioned before, the number of people in the categories, it relates to things like statistical power. So we want to make sure the number of the people in the categories, first of all, that there's a good number, right? So you see like at the bottom, so it's 7 per cell. We want 80% power to detect, an effect. It goes down to 50% power when there's 7 per cell. So it's nice to have a good number, right? And it's nice when they're more evenly distributed in the category. So just something to keep in mind. All right, now here's the cool thing, okay? So we're going to actually do our ANOVA. Here is our 6-step instruction, and we'll go to SPSS right now. First you go to Analyze, Compare Means, One-Way ANOVA, right? All right, so. Expand this box, right? We're very expansive people here in this webinar. Then we put the continuous variable in the dependent list. Then we put the categorical variable, right? Doctor prescription status in the factor. So the categorical is down here. Continuous is up here. Then we want to go to post hoc, right, in the upper right-hand corner. Click Bonferroni. Some people like to do the LSD or turkey, which doesn't really sound like statistics, but they roughly produce, the same thing. They're both based on the variance. Sometimes it's a little fitting depending on the sample structure each. And then we go to options and descriptive and continue. Then haste or paste, right? We might want to paste it. So we could have clicked OK and run it, but we pasted it. And go to the syntax, right? So don't forget, keep on saving it now and then, because sometimes, it might close on you. Then we run it, right? Bing. All right. There we go. So now we have this in the slide, so we'll go back. But there's the means, right? There's the results. There's the multiple comparisons. Let's look at it slide-wise. Either one of those will do. Okay, here we go. We did it, thank you. Now, the ANOVA results, part 1. So this is the top. We just looked at them. These are the 2 boxes, the first 2. What do we look at? There's a whole bunch of numbers. The first ones to look at, in the lower right-hand corner, we want to look at the SIG column in the second box labeled ANOVA. That will tell us the level of statistical significance for the overall test. If it's not, 0.05 or below, we don't consider anything else because the whole test is considered to be by chance, right? Then we don't consider any of the other qualities. Then we want to go up here to the first box and look at mean. So we see it's 0.002, so that tells us there's a statistically significant difference, right, between these mean scores. Right, so something's going on. That's what it's telling us. So then we go up here and we look at class attendance, and we see from no recommend to yes, the mean goes higher, 3.11, 3.55, 4.59. In other words, the average attendance for someone not prescribed class is a little more than 3. But the average attendance for someone prescribed class by their doctor is over 4.5 classes, 4.59. Then the recommended, so the doctor recommended class is somewhere in the middle, just about 3.5. Okay. So, but now you'll notice, like, it's statistically significant, but which mean is different than the other means? Is, no significantly different than yes, and recommend different than no? That's where we look at the post hoc tests, right? So you'll see each one is compared to another. Like, for example, the Bonferroni, right? Under the first column, Dr. RX, no. So that's the no category. Then in the J, the no category is compared to the recommended and yes. And you'll see in the third column where it says mean difference, if there's an asterisk, that means the 2 means are different at a statistically significant level. Right? And if there's not an asterisk, it means they're not significantly different. So we see in that first line for no, that under J, the yes category, right, there's a negative 1.483, meaning that the reference group, the no, not being prescribed, attends classes on average about 1.5 less than the yes group who were prescribed classes, right? Less meaning negative 1.483. Then in the second line, recommended, there's no asterisk, so they're not significantly different than the no or yes. And then the third line, the yes, you could see it's just reflexive. They have, in reference to the no in the J column, the mean difference is a positive 1.483. So it's the same finding, really, saying that they went to 1.5 classes more than the no. And then again, the recommended is not different. So if we take our study map, this could be pretty convenient. If we take our study map, we could just plug in the findings, right? So we could keep track, right? So you're mapping the findings while you're mapping the relationships. Okay, so we see the line connecting doctor prescribed and class attendance. You might put in a yellow box saying significant relationship, right? Okay. So now we might want to move on to our situation where variable A and B are both continuous. And you can see on the bottom of the table, when they're both continuous, such as class enjoyment and class attend, or age and class attend, we would use a correlation. Specifically here, we'll use a Pearson R correlation. Right, so what will this tell us? Let us know, right? So this will tell us if the continuous dependent variable class attend is significantly correlated with the continuous covariate independent variable, right? Age and class enjoyment, right? As one goes up, does the other go up significantly, or does it go down significantly, or is there no relationship? And of course, there's assumptions here, linearity, right? So that means as one goes up, the other goes up in a linear fashion. No undue influence of outliers. Now, like I said, that's very important for parametric testing, and a normal distribution of variables. So in SPSS, look at this, just 3 simple steps, right? So let's go and do that and look at our output. So we go to Analyze and Correlate, and then bivariate. Now by default, Pearson is checked, which is fine for us because we want to do a Pearson R correlation. So it's nice to put the dependent variable first, class attendance, right? And then to put our other 2 variables, being class enjoyment and age. So put age and class enjoyment. Then click paste, so you paste your OK. So we're going to go paste. Right? And you can also, once it's pasted, you could actually go back and then just click OK. So it's pasted, we know it's there, and then click OK, and it'll still be set up. You could still run it. And here are the correlation findings, which we'll look at in our slides. So here are the findings. So a bunch of numbers. What do we look at? There we go. Now you can see almost everything just from these numbers in terms of the 3 dimensions, right, of the variable relationship. Now, although we're not reviewing, effect size and all that for the bivariate test here, it is in the written materials, right? We're not doing it here because our big goal is to find the significant relationships. So we care about that first dimension, statistical significance, right? But in the written materials, you'll see everything assessed in terms of all 3, significance, directionality, and magnitude, okay? So for our purposes here, we see that on this second line right here, that age is 0.006 and enjoyment of class is 0.001, meaning that, right, so the intersection of class attendance, age, and enjoy, there's a statistically significant relationship between age and class attendance. Now, since it's negative for age, that means as age goes up, class attendance significantly goes down, right? 2 different directions, negative. enjoyment is positive, meaning as enjoyment goes up, class attendance also goes up, significantly positive relationship. Right? So it's not bad. So we already have, 75% filled in for our statistical tests, right? So we put in for age and class enjoyment a statistically significant relationship with class attendance. Now, the first one, right? When you have categorical of two categories, right, such as class assignment, morning, evening, and continuous, like class attendance, we use the independent samples t-test. Now, before I actually say what we're looking at here, you'll notice there's a picture of Mr. T at the bottom, which you may not have been expecting. So those of you in the 80s, and he's even still around now, but in the 80s, you'll remember there was Mr. T, and his trademark was being mean, right? So you have the t-test, and it's a test between two means. So sometimes it's a helpful mnemonic, right? That you have Mr. T was mean, and the t-test is a test between two means, right? Specifically, in the context of our presentation, a t-test will tell us if there's a significantly different mean score of attendance, how many days, a week class was attended, by two categories, those that were assigned morning classes and those that were assigned evening classes. And again, as always, there's test assumptions. Now, the important thing to know is that these assumptions exist. If you know they exist, you could look them up. It's not a big deal. But if you don't know they exist, that's the real problem, because you can't look them up if you don't know that they're there. Okay? So here they are again, and pretty much the same as the ANOVA, and also pay attention to the number of participants in each category. So there's the t-test in SPSS, right? 4 steps, and we will go implement those now. All right, so analyze, and then compare means, because we're comparing means, right? Independent samples t-test. Now the grouping variable, or you could also say grouping variable, is going to be the categorical variable. So that's class assignment. Now that's coded as a 1 for morning and 2 for evening. So you have to click on and put 1 and then 2. So to find that out, you just look in the, say class assigned. There's 1s and 2s. So you just look at how they're coded, and you put the 1 and 2. Then of course, class attendance goes into independent samples t-test test variable box. And paste. Okay. Under syntax, see now it's a big long list of what we've done so far. So if you forget, you can look it up. All right, there's our output. Now let's look at it through the slides. All right, so the t-test results. Again, lots of numbers. Which ones do we look at? All right, these are the ones to look at. So in the second box, the highlighted one is the statistical significance. It's below 0.05, 0.000, so there's a significant relationship. Also, you want to pay attention to, you see where it says F, the first little column there in SIG? That's the Levene's test. That tells us if there's unequal variance among the two groups. If it's significant, where it says SIG, see that 0.67? If that was 0.05 or below, meaning it's statistically significant, we would use the bottom set of values, right? But, right, the bottom set where the T is also negative 4.9 and the degrees of freedom is 96.4. That's if the Levene's was statistically significant, but it's greater than 0.05, so we use the top, right? Second, we want to look at the mean. So we know there's a significant difference, but who's higher, who's lower, right? So we look at class attendance. We see under class assigned in the line for morning, N is 50 people, and the mean is 2.894. So the average person assigned to morning classes attends a little below 3 classes a week, right? The evening classes, though, they go 4.48, so they go to almost 4.5 classes per week. So that's a significant difference. So then we just plug it in right there. So there we have, right, there we have all our bivariate tests telling us that there's significant relationships between each covariate variable, the independent variable, with the dependent variable class attendance. All right, so what do we do here? All right, we used bivariate analysis to identify the significant one-on-one relationships, right? We didn't look at the effect size. That's in the written materials, right? But we're going to see that in multivariate analysis, right? So the results tell us all of them have a significant relationship with class attendance. But notice, you can only see that the relationships are significant. You can't see which is the strongest predictor of class attendance, which is what the administrators want to know. But you can't see it at this level, right? Because they're only bivariate one-on-one tests. For that, you have to go to the multivariate tests, right? So there we go. You can't see it in step 5. Find out in step 6, multivariate analysis.